It is that time again, ladies and gentlemen. Good evening. Quick sound check, as always. How are things looking? Everything sound alright? I haven't changed any sound levels, so with a bit of luck, everything just sounds exactly the same. We can carry on with some nice cruisy music on in the background. Okay, let's flick over to my ugly face. Hello! Good evening. Cheers. Hacking without tea is very uncivilized, so make sure you have your tea. Those people in Discord already know what tea I'm drinking, but I'm going to share it here. That must be... Hang on, I'm going to try and connect the dots. Is that Sanoop? Is that you, Sanoop? They just pinged me on Twitter and said that you're going to be here. Is that you? Yeah, thanks for coming in, man. I appreciate you giving me your time. Welcome to the stream. Welcome to the first live stream for you. G'day, Mongo. Foob's here. Serializing me. Firefart, Mugu7, and Zorkat. You know, the regular faces. It's going to be. Well, we're actually going to get to some code today, I think, which is pretty exciting. I've been looking forward to this one for a while, so... Yeah, it's crazy. So when I look at the users listed in chat, I don't see everybody's names. I wonder if that's like you guys are marked yourselves as offline or something like that. So, stupid muted video. All right, thanks for coming, guys and gals. So tonight's tea is Gaiokuro from T2. This is a semi-regular of mine. It's a nice brew to end the day with. Highly recommended if you like a good green, grassy. Cheers. Oh, so good. So good. Yes, that's a good point. I do only see the names of people signed in, so there could be a lot of randoms. According to the stream, there's 19 people staring at the screen at the moment. But yeah, crazy. Yeah, just signed in. There we go. Oh, thanks for the follow, Rescon. Much appreciated. It's beginning already. All right, let's flick over the screen. We don't need to do any epic introductions. We're just going to continue on from where we left off. But what I am going to do, I've got a little agenda here on screen. And to start with, I'm going to say thank you to a couple of patrons. I'm not going to name them because, you know, that'd be an OPSEC fail. But just a shout out to those people who are pitching in to help me do this. So that's very much appreciated, and much love to all you people. So, questions. There have been a couple of questions on Twitter, or people sort of having a bit of back and forth with me, and we are going to cover off some of those things, but I'm going to include them in, you know, the quick recap of the version concerns and covering OPSEC stuff. Okay, but if there are any other questions that you guys might have, shout them out now while we kick this stuff off, and we'll get to them. So, g'day Archbishop. Clarko, oh yeah, just signed in, excellent. And Skorob's here as well, fantastic. Shucking a Krebs. Yeah, don't Krebs me, bro. Wasn't it Morbiz that says something like that? And there's a picture circulating Twitter with that. That was pretty funny. Don't Krebs me. All right, so where I'd like to begin is this quick recap of version concerns. And again, for those people who might have skipped a stream or two, or have hit me up on Twitter without watching the third one, which was the one we've just done. Let's quickly recap for those people so they know where we are. I'm still one video behind. Just wanted to say I lolled hard and we were used to lol no. Yeah, I'm not a fan of TED. It just doesn't seem to work for me. I'm glad you're on the same page. All right, so here are our version concerns. The thing that I think most people are confusing is that we have two different things in play here. We have a CLR version and we have a .NET version. The .NET Framework version is different to the CLR version. So given that we are looking to target an arbitrary .NET application, that application could be running on either CLR version 2 or CLR version 4. Now, among those CLR versions, there are various .NET versions available as well, and that refers to the libraries and other supporting bizos that come with the .NET framework itself, and they have their own .NET version. So that's 2, 3, 3.5, 4, 4.5, 4.5.1, 4.6, 4.6.1.3, 0.8.2, 3.1.159. Yeah, you get the point. There's all kinds of crazy versions out there. But basically anything up to and including .NET 3.5 runs on the old CLR, so CLR version 2. And anything from .NET 4 onwards runs on the CLR version 4. Okay, and we need to basically build something that we know is going to run in both of those environments. So we made the executive decision that we're going to construct 2 different instances, compile them, one for CLR version 4, one for CLR version 2. Now the CLR version 4 side is actually really easy to choose a .NET framework version because we want to basically cover as many applications that could be running on .NET 4 as possible. So we could deploy a .NET 4.0 binary on CLR 4.0, and that will work in any of the apps that we're targeting, because we know that the libraries we depend on will be sitting there ready to be used. It's not so much the case in .NET 2 land, and the reason why it's not so much the case in .NET 2 land is because in .NET 4 we've got a bunch of stuff that we can use, and there's not really anything missing from the library that's going to make life a little bit painful. Whereas on the CLR, .NET 2 is missing a bunch of really cool stuff, and .NET 3 is also missing some really handy stuff. So I threw out a poll on Twitter and said, hey, for the CLR version 2 version, which one do you guys think that we... Hey, Pong, Jono, thanks for linking the poll there, Wolf. Yep, so I wanted to know which versions you guys actually think are reasonable. Now, hang on, let me take a copy of that and I'll bring it up on where are we? Come on, Chrome, fire. Here we go. All right, so this was the poll result. We got 22% saying version 2, so that's nearly a quarter, which is quite significant. 12% said 3.0 and 66% said 3.5. Haskell are passing by. Hello! Functional programming gets me right here. Love it. Love a bit of FP in my life. It's such a shame that we're not going to get to use any FP in this particular project, other than maybe a few style sort of approaches to things. We can't make use of F#, unfortunately, but it's lovely to see a Haskeller cruising by and saying g'day. Even if you come and go, it's nice to see your face. G'day, Justin. Thanks for coming in, dude. So anyway, this poll actually echoes my sentiment, and the reason why it does that is because we go over here, just going back to our little table that shows the .NET versions and the CLR versions and what's supported out of the box. Now, come from Brian McKenna's stream. Brian, that dude is one of the smartest dudes I've met. He's a lovely bloke. I haven't seen him for ages though. Brian McKenna, Puff and Fresh, very, very smart fella. I didn't realize that he auto hosts my stuff, so that was very, very nice of him. But yeah, he's a good lad and worthy of a follow. Hey, Nullcult, welcome. Thank you for coming. Yeah, so what we're looking to do here is we need to choose which one of these framework versions we're going to use. Now, have a look at what's supported. Now, for me, it was like more of a case of, do we choose between 2 and 3.5? Like, if we're going to go to 3, we may as well go all the way to 3.5, right? Akidov. Oh, thanks, man. You actually gave me a follow. That's awesome. Thank you very much for that. So the way I saw it was, if you're going to go for the earliest possible version of .NET, then that would make sense because you're covering the biggest sort of swath of available applications. If you're going to go to 3, you kind of don't get much more as far as language features is concerned, and you only get Vista. And and at least on the desktop, and you do get a couple of extra versions of server operating systems. Whereas when it comes to .NET 3.5, out of the box you get Windows 7, which is a little bit more appealing. Now 3.5 gives you a bunch of other language/framework features which are really, really handy. So my view behind the scenes kind of was, I think we should target 3.5, which is actually the latest version of .NET 2. And given that the support for pretty much everything else has already ended, so you can see here it's ended for the 3.0, whereas 3.5 is going to exist for a little while. And I can't honestly say that any time, even in the last sort of 4 or 5 years, have I stumbled on an app that's only running on .NET version 3, let alone 2. Now, that's just anecdotal experience, but I think we can agree based on the poll results that maybe that's what we should indeed be doing. How are you guys feeling? You haven't missed much at all, Nullcut. We're just having a bit of a chat. I shouted out a couple of patrons and said thank you, and basically from here we're finalising our decision on which version of the CLR we're going to go with. Finished got, and now more hacking. Woo! Welcome, Parody. We can have immutability and functions being good. Yes, that's true. We can. We can indeed. Always good to follow Programmer here on Twitch. I'm looking and streaming some programming projects. Also maybe solving some katas in Haskell. Yeah, awesome. Do that. Code katas are really good fun and a fantastic way to practice your FP related bits and pieces. So I've done a few of those in the past, and I think I may have hidden the videos, and probably because I'm embarrassed about them. But yeah, thanks for the follow, man. So in short, I think what we're going to do is we're going to go with .NET 3.5 and we're going to go with .NET 4. So there you go. So the answer to your question, what are we doing now? We are beginning the development process of a new version of something called Meterpreter. And Meterpreter is it's a hacking utility. It's a rat that runs on a victim machine when you've managed to pop them. So this tool is used for all kinds of post-exploitation activities. So there's a lot of documentation, a lot of videos, a lot of tutorials on Meterpreter and Metasploit in general. So what we're doing here is building a new version of that will specifically target the CLR. Not that it probably really matters, but that extended support period feels nice. Yeah, I hear you. So if there's anybody out there who really is against going with 3.5 and has a very good reason, let's hear it now, because once we pull the trigger on this, we're not going to go back. Share your thoughts. And while you're typing away, which I'm going to assume you're doing, I'm going to go back over here. So 3.5 for CLR2 and 4.0 for CLR4. Forgot your T. Can't it not have T? Far out, dude. 3.5, thumbs up from Zorcat. Look, I do think it makes the most sense, and the pain that we're going to have not using it. Rastamouse, welcome, sir. Thanks for joining in again. So this is what we're going to do. I think we're going to go with 3.5. We're going to go with 4. At least 3.5 is a wider base range than the older versions. That's true. There's certainly a significant number of 3.5 apps. The thing is, if we built a .NET 2 binary, it would still run in a 3.5 runtime. That would still work. But 3.5 just gives us too many nice things. So I do think... And welcome, Miss Minty. It's nice to have you on stream again. So, I think that's decision made. As long as we get Link, yeah. Smash! Thanks for coming in, man. Welcome home. Smash has just come back from a fun ultimate frisbee tournament, and that's why it wasn't with us for the last couple. So, well done, Smash. It's nice to have you back, mate. There is another version decision outstanding. Which Visual Studio version? Yes, that's true. The Visual Studio version to use. Yeah, we'll cover that in just a minute. Now, I'm not going to lie. I'm going to make a benevolent dictator decision on that. But ultimately, what we're going to be doing will pretty much transfer to any Visual Studio version that's available, so long as it supports the target CLRs and frameworks, which to me, from my understanding, right now covers Visual Studio 2013 all the way through to 2019. Okay. Alrighty, yes, so we do get Link, Smash. We are definitely getting Link, which, to be honest, I'm happy about too. Okay. Make a decision on the framework version. I suppose I could put it in here, couldn't I? Make a decision on. Oh, I can't type when I'm on stream. Make a decision on the VS version. Simple. Now, 2013 is actually significantly older and slower than 15, 17. Now, I haven't tried 19. I haven't pulled it down. I haven't played with it. But I do have a MSDN licensed copy of 2017, and I did have that ISO sitting here, and I went ahead and installed that on my other virtual machine. So everything over there is ready to go. So I intend on using 2017 for this. It is, almost the latest version. It's got full support for the latest versions of the C# language, and I think this will be sufficient. There's a 2017 community edition out there, and right now I would say that most people have a copy of that. So, how's my night going? It's going very well, thank you, sir. I'm doing great. I can't complain. I've got my tea, and I'm sitting down in front of a bunch of virtual machines about to bash some code out with you lovely people. So it doesn't get any better than that, right? So I'm trying to figure out who that is. I think I know who that is. It's hard to know whether I should call people out and either get it wrong or say things that people don't want me to say, but I think I know who you are. Codegasm. Yes, exactly that. So, okay, so what I wanted to cover briefly was the concern about operational security, and I guess you're a rando. I don't think you are. Covering OPSEC from the standpoint of what happens when you run a CLR-based Meterpreter on a target system, and this sort of comes off the back of, on Windows 10 with AMC in constrained language mode causing all kinds of crazy stuff, limitations, shall we say, in PowerShell, which is something that's starting to make PowerShell less of an option for serious attackers. What does that mean for applications that run on the CLR? Well, at the end of the day, the operational security of CLR-based objects is not something that I'm too concerned about. I don't think that there's anything in the immediate future that would make me think, oh, well, building this was a complete waste of time. What's clear is that Microsoft are going to start doing more and more instrumentation of .NET and binaries that run on .NET. But at the moment, I would say that that's not really much of a concern for us, and I don't think it should hold us back. I do think it's a more viable option than going with the likes of PowerShell, for example. So we will target CLR version 2, .NET 3.5 for applications on older OSs, and .NET 4.0, CLR 4.0. And we will just deal with the issues of what Windows and Windows Defender or other AV throws at us at the time. Now, at the end of the day, getting this running in a target environment is technically the job of the attacker. So it's the same with Meterpreter, right? Like, there's not a significant number of bypass techniques baked into Meterpreter out of the box that you don't know about, or that don't make it look like a standard application other than reflective DLL injection, right? And that's purely just so that we don't touch disk. So we'll be following a very similar path here. They've hooked AMC into things like reflection in 4.9. There you go. So that could already be there. I mean, that's obviously something that's running inside the CLR. Maybe it's not. But yeah, it's coming. There's no doubt that it's coming. In the same way it's getting harder to run native code, it's going to get harder to run this too. But it doesn't make it any less viable to go ahead and use it now. I still think it's a worthy endeavor. So in short, we're not going to worry about it. We're just going to push on and we're going to build something. So thanks for sharing that, Rasta. All right, so if there's any questions about that, please sing them out. Whatever we do, so long as it gets heavily used, we'll start getting caught reasonably quick by default. I would agree with that. Whatever it is you build gets caught. We've been playing with a target that's got a decent endpoint solution deployed on OS X and Linux desktops, and it's picking a lot of stuff up out of the box, even standard Python stages and things like that. So it's definitely a thing. Just set up my first EC2 instance. Nothing sensitive on there. Is it even worth adding any extra security outside of the normal key pair? In my opinion, not really. Just maybe if you're the only one that's going to use it, just firewall it off to your IP. Other than that, I think you're good. Okay. Is it time? Is it time to get started with our project structure? I think it might be. So just to recap quickly, what I want to have a look at over here is the stuff to do with conditional compilation, which is supported in CLR, and we're going to make use of this because we want to make sure that we have the ability to compile in and out certain things depending on the .NET version that we're building for. And I think what these things will do, so we'll be using 3.5 and 4.0, and we should probably bake these into the file name as well, so that we know which version of the DLLs we're actually pulling out. Maybe just check services you aren't using. What do you mean? Love any bits of software just include Python now names. Yeah, I know. It's everywhere. Like you have the option to install it when you whack Visual Studio in now, which is kind of crazy. So, all right, let's get rid of this tweetage. Close that down, and here we are. A fresh installation of Visual Studio 2017. And you'll notice that I've got my Vim emulator already installed, which is awesome. So now we're at the point where we actually need to start putting our project structure together. And so as we saw in our last stream, we're going to be building probably we'll be building predominantly in the 3.5 version. And once we've done that, we'll be effectively porting our code to 4.0. And by porting, what I mean is we're just going to be sharing links across the binaries, so that source gets shared across our projects. That means, and that's where we'll have conditional compilation if required. It does make certain things a little bit tricky, but that's okay. I think it's something that we can deal with quite easily over time. And so that's effectively what we're going to do. Hey Mongo, I don't know whether you've noticed, but I even installed Ghidra for you, just so that you had something to stare at. You're welcome. Alright, so let's code folder, because I like to put things in a code folder. 2F8 AWS. I love how you guys have your own conversations while I'm babbling away. I think that's great. Right, so we're going to create a new project. Which project are we going to create first? Anyone? Clearly it's going to be like a .NET standard app. Or is it? We're actually going to create a Visual Studio solution. Another follower. Thank you for the follow. I don't know how to say it. Athorley or Athol? Sorry, that's not an I at the end. I'm struggling to pronounce some of the names that you guys are using, so forgive me for my uselessness. So we're going to shove it in C code. We're going to create a directory for the solution. So what are we calling this? We're just going to call it CLR Meterpreter. We're going to call it meterpreter.net. What should we call it? This is just the solution, so it's not really that big a deal. Nice. Trouble pronouncing names because all you old guys look... Yeah, that's true. And, I try and say it quickly, and I read over the words, and even though I've got my glasses on, I struggle to see the names, particularly with the contrast. Eighth. That'll do. Eighth. Meterpreter. Oh, that's terrible. I had actually thought of that, and I decided against it. I'm kind of tempted to put meterpreter.net because it's pretty obvious what it is. If I put .net, let's call it Neterpreter. Meterpreter. You guys are way more creative than me. Do we need to spin up another poll? No, we don't. I'm just going to call it Meterpreter.net. I think that's fairly obvious what that's going to be. So if you guys can come up with more convincing arguments down the track. Now, one thing that's interesting is like you can still choose a framework version here, even though it's not applicable. So if I choose like SQL Server, yeah, I can still choose it. C++, I can still choose it. But in the case of Visual Solutions, we don't actually need it. Yeah, thanks, man. I agree. So we'll call it Meterpreter.net. And for now, I'm going to put it in C code, and I will archive all of the stuff that we do in Git after the fact. All right. Now, the reason why I'm creating a blank solution is because I like to create that first by itself, because then it takes on no attributes of the first project that we're looking to create. So we should see it in here now. There it is. Ah, that's one thing I need to change. I want to see file name extensions. Okay, here we go. So there are a number of things that irk me out of the box about default Visual Studio project configurations when we first start our projects. So what I'm going to do to begin with is I'm going to create our first one. And then I'm pretty much going to replicate everything that we've done with that first one in our new ones. So let's begin by creating a new project. Here we go. This is where the fun really starts. Now, it is .NET Standard. It's going to be a class library because that's effectively what a DLL is. Actually, hang on a second. Class library .NET Framework. That's what we want. Now, I don't know why that's... Whereabouts is that normally? Windows Classic Desktop. Yeah, that's probably it. .NET Framework, Console App. Oh no, the class library is not even in. Oh, there it is. Yep, that one there. So even though it says Windows Classic Desktop, a standard .NET Framework library is effectively what we're looking to target. At least that's my understanding. Specific class library that targets .NET Standard. Yep. So, .NET Framework. Now, we have a naming convention to follow here, don't we? We have metserv. You reckon it's .NET Standard, do you? Or is that just a... It's actually pretty confusing. Maybe before we continue, we should... let's go ask. .NET Standard versus Framework. Let's just make it clear. Let's have a look. .NET Standard is a specification which dictates what the base class libraries of different .NET versions should implement to unify base class libraries. Platform means full .NET Framework, .NET Core, blah, blah, blah. It also enables code sharing between applications that run on these different platforms. For example, a library or components developed on top of a platform that implements specific .NET Standard version can be shared by all the applications that runs on any of the platforms. Ooh. It's not too... I'm afraid it is too late to consider Haskell. The .NET Framework is released. It serves as a general app. After this new version of .NET Framework called .NET Compact Framework. I remember that. You address this problem, new web compiling libraries introduced called portable class libraries. I remember portable class libraries as well. Assuming you're creating a portable class library, which we kind of aren't. Introduction .NET Standard. So, here we go. So, .NET Standard solves all these in a different way. Provide an API specification which all platforms should implement to remain .NET Standard compliant. This has unified the base class libraries of different .NET platforms and has paved a way to share libraries and has also brought BCL evolution centralized as seen below. Well, 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 isn't this interesting? Let's have a look. I might zoom in on this just a little bit because that image is hard to read. So, .NET Standard 1.0. You'll see that completely cuts out .NET 2. So there you go, that answers that question, which is what I thought might have been the case. See how we don't have WinForms, web forms, blah, blah, blah. Oh, OS-specific APIs like registry and app domain. Yep. So we're back to what we thought. So we're going to use .NET Framework. Now, remember the name of the very first component that goes across the wire once we start staging a Meterpreter instance. It's going to be metserv. Now metserv obviously is a DLL, but here we're going to include net30 in the name because we're going to end up building two versions. Sorry, not 3.0, 3.5, .NET 3.5. Metserve.NET 3.5, and that'll have a .dll at the end of it. And then we'll create another one called Metserve.NET 4.0, which will have the 4.0 specifics. Now we have to make sure that we target .NET 3.5, given that that's what it is that we are going to be using. And let's get cracking. It's quick, isn't it? Not. Now, hey Vikrant, welcome to the stream, mate. Haskell is safe because it just makes computers heat up without actually doing anything. Only if you output something, right? If you don't output something, then you're good. Now, I have not gone through and completely reconfigured. That's probably a bit too big. Reconfigured my Visual Studio configurations so that it all works nicely the way that I want. So I may tweak things on the fly. One of the first things that I tend to do though, and we're going to have to do here, is go and reconfigure a bunch of build related stuff. So first of all, I'm going to get rid of this default namespace. So the default namespace tends to match the project name. Yeah. So we need to have a default namespace. Now I'm going to do it based on a number of things. And what I want you guys to have a think about is, what will this mean from an operational security standpoint if we have a default namespace set to Meterpreter or MSF or something along those lines? Null cult, that was me installing that for Mongo. MongoBug was the one that called me out for that. Compiler docs. So what is our default namespace going to be? Because I'm going to change it here, and that means that when we in future create new class instances or whatever, then this is going to whack the default namespace in here for us. So what are we going to do? What should we call it? It's too late. Look, you know, using names like Metserve tend to sort of make things stand out, but maybe we should like never gonna give you up, never gonna let you down, totally not Meterpreter. Totes legit. So many fantastic suggestions. Now what I actually want to do is put all of these binaries in the same namespace, right? So I might just prefix it with MET. We could use the MET or MSF. What do you want to do? MSF or MS? Because MSF implies Metasploit framework. MET implies Meterpreter. They're both kind of obvious, but at least they're abbreviated. Net system. Firefight. OJ, come on then. This is funny. MSF, a bit like Microsoft. Yeah, that's actually not a bad point. So maybe we should just change our default namespace to msf.metserve. So for here, we do need to fence off the components a little bit, but I do want to put things all in the same. Oh, sub 7. Microsoft.Windows. Can get in trouble for that, you know. Any objections to msf.metserve? So there'll be an msf. Extension name. In fact, we don't even need to call it Metserve. I mean, as long as we have our assembly name set correctly, we can call this whatever we want. So default namespace can just be MSF if we want it to be honest. You have a think. We do need to fence off this style of code, or this area of code, which is effectively, you know, the core related stuff. So maybe we could call it msf.core, but then again, that implies it's the core of MSF, not the core of Meterpreter. Naming is hard, man. It's one of the hardest things in computer science. So what are we going to call it? Met.core. I like that. I think met.core plus caps. Refactor. All right, we're going to call it met.core to begin with. Okay. Now there's nothing in here in particular. We're not going to do code signing. We're not going to do code analysis, all that sort of stuff at this particular point. There's nothing in here we really need to worry about too much, so let's just save that. Now, there are a bunch of other bits and pieces. Actually, we need to change one thing. I think it might be in build. Here we go. So output path. Now, by default, what happens is under each project, you end up with folders that contain the output, like the DLLs and all of that sort of stuff. And the folders are underneath each one of the projects. So in order to get access, to all of them, we have to go into each individual folder, which is just crap. So instead of doing that, what I want to do is I want to change this so that we can basically poke it into the parent folder. So the parent will be the solution folder, and then we'll call it bin debug. Right? And then we'll do the same for release so that everything basically copies into a debug or release folder. All right, so let's go to release and we'll do the same for release. Okay, we'll keep warning level as 4 because I like to make sure that we see all of the warnings. And then what I'm going to do is we're going to add our first class. We're going to add a CS file. Now, pick a class name that we know we're going to need, because all I'm going to do is compile this and just to make sure that things appear in the right location, right? No, I am not doing that. I agree, Firefart. I will definitely treat warnings as errors. Where is the setting for that, actually? Logger. We're not going to be logging anything. Transports. Well, you know what I was going to do? I was going to go packet. Packet or TLV packet. But we're going to end up with a packet somewhere that we can read information out of, correct? So, at the very core level, we are going to be sending and receiving packets. So, I'm pretty sure that a packet is going to appear. Chip packet. So, I'm just going to put packet in. Lays. Alright, and because I am a stickler for not putting things in that I don't need, I'm going to get rid of all of the includes. Now this reference stuff here just pisses me off, so hang on a second. There's some option somewhere to turn that annoying thing off. What is it called? Does anyone know? Projects and solutions. Is it general? There is there's a setting that turns off this little annotation thing, and I can't remember what it is. Does anyone know? Type reference into the search bar. Place system. Highlight references to symbol, highlight related keywords, outlining. Highlight references. Am I missing it? I hate it. I hate the references thing. Editor help. Oh, is this it here? Automatic insertion, pretty listing, automatic insertion, go to def. Wasn't it the first one? I don't think it is. Place system directives. That's just to do with sorting of namespace related stuff. And it's not outlining, it's not structure, it's pretty listing. Preview, rename, go to definition. Don't put by ref. There's something in here for sure. Code lens, thank you. Boom. Turn that off. Hate it. Yeah, that's better. Ugh, it's so much cleaner. Thank you, Atwolf. You've saved me. Yeah, it is. Hey, it's good. I don't even have to Google stuff because you guys are frantically Googling things for me. Okay, so see how there's a bin debug in here already? Now, if we get rid of that folder. Now, obj files should still appear here. If I build this. Hang on, we want to view Where's the build window? For some reason the build window is not present. Output. There we go. Okay, so that built. And there hopefully won't be a bin in here. It'll just be up in bin. Debug. Fantastic. So that means that hopefully we'll get all of our DLLs and whatnot out in the locations that we want. Let's do the same for release. Oops. Fat finger. Bin meterpreter.net. Bin. Ooh. Yep. Bin release. There we go. Now we actually don't need PDBs for release, but I'm just going to leave it there for now. Yeah. Twitch-driven development. I've never done development like this before. Usually I'm just a dictator. And I will kind of slip into that mode every now and then. I apologize for that, but that's pretty much how it's going to stay. My bad. Okay. All right, so with that in mind, let's go ahead. Now we may well sort of move these bits and pieces around into sort of sub namespaces and all that kind of stuff, but for now we're just going to start with this packet. Now at this point it's probably worth considering what we're going to be doing with testing, right? What approach are we going to take with testing? We are going to throw some standard unit tests in along the way to make sure certain things are behaving, right? We might do some sort of integration testing, blah blah blah. The problem there, like for me, is that if we go too far with this, we're going to end up taking the enterprise development approach of interfacing everything so that we can mock shit out and all that kind of crap, which I think is just over the top. F-check. Isn't F-check like quick check for .NET? Is that what that is? I think I vaguely remember playing with that. A language agnostic. Is this the one? Orchestration tool for integration and system testing. I did take a bit of a punt on the name. Is this the one you're talking about? Testing microservices. Ugh, God, microservices. I don't think this is what we're looking for, to be honest. FS check. Yeah, that makes more sense. F# check. That's basically what that is. Random testing for .NET. So this has actually been around for quite some time. It's a tool for testing .NET programs automatically. Programmer provides a specification of the program in the form of properties. So this is property-based testing, right? That's obviously satisfied. So FS check and unit and actually that plugin can be installed from NuGet using your favorite package manager. Users have also created integrations for all those other things. So, do we want to get into property-based testing here? Because that's going to extend things significantly. Yes, formal proof is indeed better. Hey, I don't have time for that. All right, so what I'm going to do for now is I'm going to leave this sitting here so that we can come back to it. And we're going to start by looking to implement some packet-related stuff, and then we'll look to test it. Okay. And we might do this by capturing a real-life packet from an existing session or something, and taking that out and building a spec against it of some kind, right? So there is actually no specification, and there's no documentation around that says this is what you need. So we have to go digging through existing source code to find it. All right, so we know what a TLV packet looks like, right? We need to be able to construct one from a stream of bytes. But it's not that simple. Because in order to construct one from a stream of bytes, we need to actually parse a subset of bytes first. So we know that pardon me. We know that we're going to have a packet header that is something like 21 bytes or something. We need to read 21 bytes regardless. After that, like if we're using a stream-based socket, such as a TCP socket, we need to read the header, and then we need to quickly parse the header to determine how long the packet is, and then read the rest of the bytes until that packet has been completely read. If we were doing HTTP, then we kind of know that the packet comes in the entire body of the response. So the behavior of parsing a packet is actually a little bit different depending on where it's read from, right? So we need to provide some kind of stream style abstraction that will allow us to go regardless of the transport. We're going to give you some bytes that we've read in, and then you're going to tell us if you need more bytes. And that kind of doesn't make sense for HTTP, right? So do you instead delegate the parsing of just the header? So do you have like a packet header, and then you instantiate a packet header when you know you've read enough bytes? So these are the kind of things that we need to consider, right? Because with a TCP stream, we could read 4 bytes and then another 8 bytes and then 50 bytes. It just depends, right? Data comes in at whatever pace. HTTP, we get the whole lot. So yeah, we need to think about what that looks like and how that works. And then once we've got that packet, we need to be able to completely pull it apart into its independent pieces. And how far do you go with that? Do you strongly type every possible thing that can come out of a packet, or do you leave it as a kind of fairly weak type dictionary? I have some thoughts. What do you guys think? This isn't just me, remember? It's probably easier for me to ponder this because I've had to work with this before, whereas for everyone else out there who hasn't played with TLV packets and the code that actually manipulates them, it's very hard to have an opinion, right? Hard type everything. See, now I'm pretty keen for strong typing all of the things, right? So instead of, say, having a what's it called? Instead of just having like a string type that represents an identifier, we actually have an identifier type, and that identifier type wraps up the value under the hood, right? How many different kinds of packet? Well, we've got the same kind of packet, but the TLVs themselves are different. Now let's pop over to, let's go here. Now, what am I looking for? I'm looking for class packet. There it is. Right. So there are 4 types of packet themselves. There's a request response, a plain request, and plain response. Now, I've never actually seen a plain request or plain response used in code. It doesn't mean to say that it's not, but clearly we need to handle for it. So all of these definitions here refer to the types. Okay, they are specific to like TLV element types. It could be like a TLV session ID, a session ID, which is actually a byte string or an array of bytes. There are other ones. So, for example, you type migrate arch, migrate entry point, proxy. These are all core ones, right? So TLV type, encryption symmetric key. So all of these things here, you can see they're made up of meta types and their own identifier. So we need to map all of these ourselves manually. So in other words, for every single one of these strongly typed TLVs, do we create a type that represents exactly that? The only problem with doing this is the way that we've got to think about how we would consume that, right? How do we consume that? How do we get access to it? So a lot of the time you might say, right, I've got a packet, and on this particular packet, what I'm probably, let's say this particular packet I know is a request packet. Does that have a strong type? Well, a request and response literally only have one difference, and that is this. Implementation-wise, they are exactly the same, because you can add stuff to a request and pass it on. You can add stuff to a response. So what we want to be able to do is like create on the fly. We want to be able to create things of certain types and add them to a packet so that we can return, right? All of that kind of stuff comes with an overhead. So yeah, the specific type should just be attributes within the base types. Quite possibly that, right? Quite possibly that. But here's the thing. So we can create these epic object graphs, which are really, really easy to do, and just say, this is what we want our packet to look like, and then we can just serialize it, and that's pretty good, and it makes the interface fairly intuitive. And we could even make it fluent, which a lot of C# related people really enjoy doing. So I'm kind of a fan of that idea. But the thing is, with strong types, let's say you get a packet, okay? Now that packet might be it comes in and it's something that says, I want you to invoke this Kiwi command, right? Which might be, go and run logon passwords to dump stuff out of memory. And behind the scenes, actually that's a bad example. Let's not use that example. Let's use the example of doing a directory listing. So we've got a packet that is a directory listing. Do we have a strongly typed directory listing packet? Do we? Because if we do, we need to know that it's that up front before we deserialize it into that thing, right? So we would need to effectively have a custom deserializer that knows to deserialize it to that type, which is definitely possible. We just end up we end up having this fairly significant mapping between, a serialized type and all of the possible types of packets that have come out of it. And what if those values aren't there? So this is one of the things that I've been wrestling with in my head for a little while. Like, do we end up wrapping every single one in a strong type? Or do we just provide a very simple mechanism to say, right, I want to add this type of value and only handle the base types? And from there, be able to just say, it's this kind of value. It's got this identifier, and this is the value I want. And it knows how to effectively serialize that stuff on the fly. Implementation should be separate from the representation. We can define an ADT and it gets spat out using an interpreter. Yep, we could do that. We could do that. Is that what we want to do? And does everyone understand that? Right? So let's have a look, for example, at... See, and there are cases where... Hey, Pelias, thanks for coming in, dude. No, it's not done. So there are cases where, for example, your packet is literally get the session GUID, or get a UUID, or get a machine ID, and the actual content of the packet is just the name of the command. So you have a class with no attributes, right? Then, if you have a request packet of a certain kind, then you've got to have a response packet that matches a response to the request, right? So you can have, for example, machine ID packet request and a machine ID packet response. Makes a lot of sense then, because for the cases that the type doesn't actually exist, the interpreter would just fail on it. Say, yes, but we're living in a very different world. We don't want to fail. Because if we fail or something bad happens, we're not going to throw exceptions. We just need to return what is effectively a, sorry, we don't support that command, and things need to continue to run. Yes, fault doesn't compile. Exactly that. But, yes, try catch everywhere. So this is a really important thing to cover, because this kind of issue is going to come up pretty much everywhere, right? So there's a base TLV value, and that base TLV value is going to have a size, a identifier, and which is effectively the type, and the actual value itself. So when we're constructing our packets, do we do that on the fly? So we need to have a think about what that actually looks like. It's very, very procedural in C. So the way that it's written in the native Meterpreter at this current time is, when you create a packet, you write values to the packet and they're immediately serialized. And there's a realloc call in order to create a byte stream that's big enough. And so when you add a string, it serializes that string, reallocs memory, sticks the string at the end, and then waits for the next one. So every time we do something, we realloc memory to build this packet up, and then when you say, right, I'm done with that packet, we encrypt it and send it down the wire. In reverse, obviously when we receive the packet, we decrypt the packet, and then we have all the TLV values sitting there ready to go. We don't actually immediately parse those into like an object hierarchy or anything similar to that. We basically say, right, now that I have this stream of bytes, which is effectively the packet, can you please go and get me a string value that is identified by RSA pub key? And then behind the scenes, the code goes, right, I'm going to iterate over the TLV values in this packet. And I'm going to say, right, here, this one here is the pub key. So we're going to convert that to a string and return it based on what data happens to be in that packet. So what we need to do is we need to have a think about, do we want to do that deserialization completely up front? Do we want to do the serialization on the fly, or do it in one massive hit when we know how big the thing is going to be? So all of these things are a trade-off of, speed and memory usage and usability and how easy the code is to read and how easy it is to write the code. So every single TLV packet we support, do we want a strongly typed request and response? From a readability standpoint, yeah, that makes a lot of sense. But at the end of the day, every single packet is just serializing one or more values of primitive types. And is that all we really need to do? Are there some types of packets that can exclude because they're not important? Well, to begin with, there's a lot we can exclude because we're going to be doing this piecemeal. However, there's still a significant number that we need to kick off to begin with in order to support the initial handshake. And what I will show you with the initial handshake, probably over the next couple of streams, is there are a number of messages that get sent to begin with in order for things to even kick off. But again, before we get ahead of ourselves, I'm harboring on this packet stuff because it's actually a single piece of work that we can focus on and hopefully bash through in a relatively small period of time. But from there, what we actually need to do is go, right, what's going to house this thing? How is that going to look? Should we start off with a very simple executable? And we're going to hard code some configuration because we are going to need transports. We're going to need session-related bits and pieces. So there's so much stuff to consider. I'm just focusing on packets because I know I can create one and I can test if I can serialize it properly, which is a really small piece of work. Okay? Does that make sense? And what I like about this, the idea of at least initially loose typing this stuff, is that if we type it loosely and we just basically handle the parsing of a stream of bytes that return a TLV value or a TLV type, then what we end up with here is we end up with the ability to load every packet that comes in, even if we don't have the types yet. And then as we go through implementing bits and pieces, we can say, well, we can read this value off the wire now, but we don't actually need a strong type in which to do it. And that's the approach that the Java version uses. It's the approach that the Python version uses. None of those actually have strong types for TLV related packets. Now, I'm a big proponent of strong types. I do love strong types. But when it comes to this sort of request response stuff and the arbitrary nature of what these packets may look like, I think to begin with, it's not necessarily worth implementing that. What do you guys reckon? Now, I know we've got some purist programmers on the stream. Everything should be typed. I vote for using loose parsing, using binary reader and binary writer, and a big switch case statement. Well, the good thing is they don't actually have to be that big because of the way the TLV related bits and pieces work, right? We can get smart/cheeky about that. Make everything harder for fun. I like you. I like the way you think. I like types. Is that it? That's how you see it the same. Everyone's been doing it on loose typing. Yeah, so I'm not using that as an argument. That's not an appeal to authority by any stretch. Make everything harder for fun. Vim. Hey, Vim's not hard. It's just a muscle memory thing. We're not going to go into that again. All right, so what I really want to highlight here, though, is that the idea of a packet and the idea of a TLV are not the same thing. But if we use loose parsing, we need more unit tests to catch errors. Yeah, we do. But remember, I mean, there's a question of, do we parse up front or do we parse after the fact? I think it's worth parsing up front. So once we get our stream of bytes, we can basically just parse that into a TLV value or a TLV. So the way I see it is this, right? We have a TLV type as well, right? Because the TLV has a type, a length, and a value, right? Does this still have the refactoring stuff in it? Move type to tlv.cs. Hey, winner. See that? Don't know why. Hang on. Oh, there we go. Yep. So a packet effectively will have a number of TLVs. But the idea of having like a collection of TLVs versus a packet, I think, are very different. Because to begin with, like if we're constructing a request or a response, that the idea of a packet is something that gets shifted up and down the network. Whereas a TLV is kind of agnostic of that, right? Which is why I think a TLV should sort of live off by itself. A TLV will obviously have a type and a length, right? It also has a value, and that value will vary depending on what it is, okay? So what I'm going to do is this. To begin with, we're going to have a public TLV type, okay? Now I can't call it, I can call it type. And we're going to give that a get. So going to need a TLV type. Now, this is where like a bunch of magic is going to happen. Now this has to be a unsigned 32-bit integer. Right? Can we do generics? Yes, we can. Isn't a packet exactly just a collection of TLVs that you leave another concept up top of packets, which are commands? Well, yes. A packet is a collection of TLVs that can be and may be encrypted that has wrapped in a header. That's what a packet is. And that includes session-related stuff. So what I intend on doing is when you create a packet, you either give it a stream of bytes that you've read, or you give it a bunch of TLVs and some session information and say, go ahead and create that packet for me. And so the packet wraps up all of the list of TLVs, but it has just a little bit more, if that makes sense. What's the rationale for using uint32 over using system? That's just me being kind of picky, so we can get rid of that and hit using system that way if you prefer. I just did that. The reason why I typed system dot to begin with was to help me remember exactly what the specific class name is. Now that may map directly to a 32-bit integer, but no, it's not. It probably is just a 32-bit, like a uint. A uint is probably 32, but I think this highlights the fact that it is going to be 4 bytes. Which is really important, right? Now, if we look at, where are we? Let's go back over here. If we look at this, for example, right? So all of these ones are the important ones. These are effectively the ones that we really care about. These are the base types, right? Oops. Enable the clipboard. Now, hopefully, I wonder if this goes nicely across. Yeah. Okay, so just wanted to put those in there so that we can see. What's the rationale for using system? Oh, I've already answered that. Did that make sense, Rasta? Okay, so one of the things that's going to suck about this is that the TLV types are used across all of the things, including extensions, right? And so if we use an enumeration, which we really want to use because, you know, that's how this stuff should work, then we're going to need to include things like extension-specific types. So if you load Xtappy or Standard API or Kiwi, they all have their own TLV packets. Sorry, they're packets with TLVs in them that have their own types. So this TLV type should technically, behind the scenes, support all of those types. Does that make sense? And so that basically means that Metserve, or I should say our core part of Meterpreter, needs to know implementation detail or identifiers for other types. And this actually hits on a really key point, because if we implement all of these things as a strong type, then the packets need to be able to cater for types for extensions that have been loaded and then maybe in a completely different app domain, or if we effectively don't know what that type is. So we would need to sort of extend the packet functionality on the fly when an extension is loaded, which is pretty tricky. So what I'm going to do to begin with is, hang on, tools, options, environment, keyboard, PIMU.key, press Control V in text editor. Right, so there we go. I had forgotten to do that, so that's better. Visual block mode for the win. All right, so this is basically what we want, right? We've got TLV type as an enumeration, and we're going to keep it for now, okay? And we're going to call these, instead of meta type, we'll just call them meta. And we're going to start with 0, right? Does that make sense? Now, let's see if we can do some magic for a minute. Let's do some macro magic, right? Let's do this. Let's see if this works. I love Vim, it's so good. We can get rid of these types. That's pretty cool, hey? Oh, that didn't work. That did. Now, why is this not happy? Check that out. Represents a 32-bit signed integer. Cannot be converted to a uint. Ah, that's right. So I need to specify, do I put a u after it? I can never remember the syntax. Visual Studio Shortcut Magic tutorial. Yeah. So this is interesting, right? See how these are fine? Represents a 32-bit signed integer. How do we specify unsigned? Did we do that? Nope. Let's check the documentation. C#.net unsigned integer literal. There's got to be a way of specifying it. U. It is U. Unsigned int. Why didn't that work? Aha. That didn't work either. Why is that not working? Cannot be applied to operands of type uint and uint. Really? Well, that, my friend, is terrible. Uint 32. Oh, I can't type. Cannot be used like a method. You're right, it can't. So let's do the casting thing. We're already casting. That's got to be a good sign, right? So this is interesting because cannot be converted to a uint. Use unchecked syntax. So this is interesting, right? Type safing is freaking great. So what I'm going to do is I'm going to undo all of that stuff that I've just done. The problem that we have is this value here, right? So that returns... What we may actually have to do... Is that all it is? Aha! Look at that. Thank you, Mongo. Oops. Winning. I just learned something. So it's the actual value, not the shift. That's because I'm so stupid. That makes a lot more sense. Anyway, hopefully we all learned something there. One is we need to actually put the value that we're shifting. And two is that Vim is amazing. Let's get rid of that. So they're the meta types, and the meta types are the base types, right? And so the base types tend to they're basically what everything else is constructed out of, and so we know effectively how to deserialize it, right? Exclude compressed from the mask. Yeah, right. So we need to take all of these and exclude compressed from the mask, since other meta types, raw, can also be compressed. I wonder what that's actually used for. That's interesting, hey? Oh, that's only for inspection. Really? So in other words, in the entire code base for Metasploit framework, that meta mask is not used except for when it's dumping. So we're not going to bother with that. Now, we are going to need these. So let's do that. This is going to get messy quickly. No, let's do this. So. Now, it's interesting that obviously we've got some that map to the same. Now, these are all kind of used and masked together. Now, actually, we can specify, I can't remember what the syntax is, but we can specify that this is a set of flags by giving, this is a flags attribute. It's pretty clear that they are all TB. That's true, it is. We can get rid of those, I don't mind. Less typing. We were happy with that? Now what I want to get to is a point where we've actually just got a simple subset of core TLVs so that we can read them. What's interesting about this is like the types themselves, we don't actually... Hang on a minute. Yeah, we do. Well, we don't actually need them as far as reading the value is concerned if we want to actually use strong typing, right? Because what we could do... Could we? Oh, we've just lost music. Or is it buffering? Did you guys hear that? Oh, here we go. So what would be nice, right, is to be able to do something like public t get value of type t and give it the it'd be good to be able to do things like this. So the cool thing about doing this is like we can, I think we can say where t is it. You can add constraints and whatnot, but basically what I want to say is like if you can give us a primitive, then we don't actually have to do the casting up front, right? So for example, if we were to expose that and we also had this TLV type return null. Okay, so we've got two kind of potential APIs for extracting values out of a TLV type with some, shall we say, primitive kind of capabilities. So if the TLV type mapped to a string or a GUID or a byte array or an integer or something along those lines, then this code pretty much is easy to do, right? And we don't really have to do much like checking the type, although we probably would be better off doing that. Here we'd actually be casting the value that we found back to the value that's requested. So let's just do public void foo. This is our little testing area, right? So if we wanted to get a string out, we could say like var name equals this dot get value string and give it TLV type dot, I don't know, meta string, just for example. So that would then mean like down the track we could say TLV type dot password, and so var password equals get like TLV dot get value and give it the string, for example, and that would give us the strong type. If we did it some other way, like password, if we did it the other way, we would actually have to go string this dot get value without using the generics version and TLV type dot meta string, for example. So you can see here we're casting, and here we're kind of leaving the typing to the function. Yeah, we're mixing, we're talking about design, we're talking about syntax, we're talking about different options for pulling the values out of a serialized stream of bytes and finding the sweet spot for strong typing versus fairly loose typing, right? So that's what I'm focusing on at the moment. So if we used a more specific example, so let's go with a result. Is it a result that we want? Yeah, let's do that. So excluding this, a result equals a meta type uint ORed with, what was the value? 4. Should make that a U, hey? Do the same with all of these to be consistent. Okay, so if we wanted to get the result of a function call, then we would go var result equals this dot get value uint32 TLV type dot result. And that's how we would get the result out of a packet. Now think about, and a result is a bad example, I guess more so because the result is what's checked on the other side and the MSF side. But that's effectively what we're talking about, right? Do we want to mix meta TLV types with the concrete types in the same enum? Now, if we don't do that, then well, we kind of have to. We actually kind of have to, yeah. Because not every single packet that we send back and forth across the wire has a strong type. There are some packets that go, okay, I want a string value. I don't really care about creating a strong TLV type just for that value. So I'm just going to use string. Does that make sense? There's also the notion of group packets, which means packets within packets. So if you have, and collections of results. So you might return, like when you call log on passwords, you return a huge list of username, domain, password, username, domain, password. There are other things like a file listing that will just return a list of files, and each one of those is just a string, and they all have the same type, right? Does that make sense? So meta types will be used as much as concrete types, so they are effectively the same thing. But that is a really good question. Ideally, it'd be nice to sort of separate those out, but again, you start separating them out, and then you have to separate them again because of the extensions, but the extensions need to all use the same TLV type mechanism, at which point you end up going, okay, well, I've got my own TLV. Do I cast that value specifically into the enumeration that we're using and let the thing handle underneath the scenes, which would actually break because unless you use a value that's specifically part of the enumeration type, then .NET will shit itself. So at which point do you go, okay, well, let's just convert that to a uint and use the uints anyway, which means that we're back down to primitive types and we kind of lose the bonuses of the typing. Either that or you end up with having strong types that aren't enumerations and you try and kind of create a hierarchy of objects and whatnot. I think for the sake of what we're trying to do here, that kind of complexity isn't necessarily going to add a great deal of value. But I'm just exploring the notions here, right? Because when we call, for example, give me a result, when calling it, are saying, okay, well, I am expecting an integer. Because but the integer is actually inside this type. We have said inside here that result is actually an unsigned integer, right? So we're kind of, the knowledge of the value is in here already. But in order to get it out strongly typed, we kind of have to say this is what I'm expecting at the same time. So if we were to do it in here, then the type we need to effectively check. So we could say, you know, if type, what are we looking for? And bitwise and TLV type dot meta uint. So, hang on a minute. Operator can't be used with. How do we do the flags thing again compared to? Can't remember how to do the bitwise anding. C# flag enumeration. Let's have a look at some examples, because it's been a while since I've done this before. Just confused because currently the TLV class has a type member, but then you're passing another TLV type into get value. Sorry, what do you mean? Ah, yes. Okay, so that type, this one here, yeah, you're right. Actually, you are dead right. So you want to, yeah, I shouldn't actually have to specify the type. It should be baked in, right? I am conflating a little bit. So we should be able to go like this, right? That's what you meant. Like that, right? Does that make sense? Now I need to quickly check the flag things. I think so, unless I'm... No, you're dead right, mate. So let's see. Where's the flags, bits and pieces? Here we go. So we can OR. Flags bitwise, yep. Yeah, that should be fine. Equals. Oh, I just need parentheses. So it's just order of precedence. There we go. Okay, so tell me why you should get in the habit of doing this instead of this. You probably can't do it in this language, but in other languages you can just go like that. Tell me why you shouldn't do that while we're going ahead. So here, we should also be checking things like and type of t equals type of uint 32. OJ yells at you when you're trying to get him to debug your code. That's true. I do that. I absolutely do that. The reason why you shouldn't, in C at least, is because when you do this masking, there may be cases where this thing that you're masking out has multiple flags set, and the type that or the value you're checking against may only have one of those flags set, and you'll still end up with a non-zero result, but it's not the exact type that you're looking for. So you should always do the mask and check to see if it matches the exact type that you're looking for. So here we're doing kind of like a very basic check to say, okay, well, we are an unsigned integer. That's what that says. Let's make sure that you're asking for an unsigned integer. Because if you're not, then I'm not going to give you one because I can't, right? So here we would use like the .NET functionality that will allow us to read stuff out of a byte array. So behind the scenes in a TLV, we've actually got an array of bytes, right? And that array of bytes is where we're actually going to be doing the conversion. Now we've also got the problem behind the scenes of if we allow people to read the values in this way, then we kind of need to retain a reference to the subset of data that we've actually read. Yeah. So if we take this approach, well, we're doing like a lazy kind of thing rather than a proactive sort of thing. So what we possibly should be doing instead is creating, like we actually have like a deserializer that creates the TLV types and actually gives it the values during construction. The problem there is we end up with TLV types that basically match each individual TLV type enumeration value, if that makes any sense. Does it make sense? I feel like I'm babbling and there's not a lot of commentary. I'm worried that I'm losing people. It is a bit confusing, right? And trying to get what's in my head out on paper so that we can play with it is a different thing. So the two options we've got is, do we just give the TLV type itself a reference to the array of bytes that have come off the wire and let it handle that? Or do we instead pre-parse and go, I want to create like an array or a dictionary of objects that each have their own identifiers that map to TLV types. We do need this in some form regardless, so this is going to stay as it is. So to give you a little bit more clarity, if we had a constructor, we had a TLV constructor, right? And what we do is we get given the TLV type because that comes off the wire. We get given a byte array which contains the data. Yeah. Why am I going class? That's all I need. Okay, so we've got a constructor. And what we have behind the scenes, let's say, is a private object, because we don't actually know what it is, right? We have an object, which is the value. Now, some people have different opinions on how you write local variables versus member variables versus whatever. For now, we'll not worry about that argument. So at this point, what we can do is we can say, right, if we've got one of these, yeah, then the value equals, you know, whatever it happens to be. Convert dot to, I don't think we can use to uint32. There isn't a uint32. Yes, there is. So we've got a byte. I don't think there's a byte array. What's the converter again? Hey Barney. Is it a byte reader? Maybe we could just give it a byte reader. That may actually be useful, because then, yeah, I don't know. .NET binary reader. System.io.binary reader. See, there's a lot of stuff in here. Okay, so this is definitely up for discussion, Firefight. So we can have a binary reader which wraps up all of the TLV values, and then it's up to something to read the type and value. I don't really have too much of a problem with that, to be honest. That's not really that much of a concern. But hang on, where are we? That would mean we would have something around this to orchestrate it. Okay, so we would instead have a binary reader using system.io binary reader. So we could basically go reader.read. Is it uint? Can we do uints? Please tell me. Yes, we can. Read uint32. This dot type private uint32. No. TLV type. You know what? I don't even need to do that. I can just do this. This dot type. Now we need to read an unsigned integer, but we want to be able to cast it to a TLV type. Tell me why this is a bad idea. Anyone? Why is this line a bad idea? Is the encoding used by binary reader going to match what Metasploit uses? Yep, it should be. Because it's all like, I mean, for integers, it's just network byte order stuff. So that's for lengths and ints and all that sort of stuff. Everything else shouldn't be a fine. I don't have a one-to-one match. So what do you mean by that, Jono? I don't have a one-to-one match. Do you mean in here I don't have all of the TLV types? Is that what you mean? There are more ints than TLV. Yeah, exactly. So what would happen at runtime if I left it like this? Boom. It would throw an exception, right? So I can't do this. I couldn't do this. I'd have to wrap it in a try catch. Okay? So that's what this concern would be. But for now, I just want to show you the kind of thing that you would do here. So you pull out the type from the reader. Actually, you wouldn't do that first. You would have to go var length equals reader.read uint32, because the first value that comes in is the length, right? So you got length, then type, and then the value, remember, based on our discussion before. So what we would need to do is, we know for sure that if that type is a unsigned integer, then value would be reader.read and basically just read another uint32. Now the assumption here is that the length that we are given is 12, because when we specify the length of a TLV, that includes the header, so there'll be 4 bytes for the length, 4 bytes for the type, and then however many bytes that represents the data. So here, this looks messy, but basically the actual length of the data would be 8, right? And so the value would be this. So we subtract 8 bytes because there's always 8 extra bytes in the length field that take into account the length and the type. And then from here we read int32. Now what we should do is assert that the length equals... is there a nice way of doing this? Is there a size value? I don't think there is. How do we get a size? Is there a size of uint32? Does that actually work? Yeah, guess it does. So what I'm saying here is, like, if the length that we get out does not map to the type that we're expecting, then that's probably a bad thing. Yeah? Does that make sense? Hello? I've lost a bunch of people tonight. It does make sense. So if we were then to do things like this, meta string, and this was a string. What is wrong with this? Oh yeah, I need that in there too. Can anyone tell me what this means? See how I've got get and private set? What does that mean? Returns a string prefixed with the length. The string is prefixed with the length and is encoded as an integer, 7 bits at a time. Yeah, we're not doing that. Read bytes. Int count. So yeah, this is where we would go. Give us the length. Okay. It's pretty irritating, isn't it, when you say, I'm going to give you a length of something, but the type system says, oh, we'll let you specify a negative length. You accessing the setter from the inside. Right, exactly. So, this type value is just a property. So it's not a function, it's a property. And properties have getters and setters. Okay? Here I'm defining the property as public, which means anything using the class on the outside can see it. So I've defined an implicit getter, which means .NET will fill in a member variable behind the scenes that maps to that type. And it is publicly gettable, but it is privately settable, which means that the only code that can actually set this type value is inside the class. So see how I'm going type equals this? If someone created an instance of this TLV type and then went TLV.type equals whatever from the outside, it would fail because it's actually not publicly settable, it's only privately settable. Does that make sense? I hope it makes sense. Anyway, this whole get value thing would change completely. So I'm going to get rid of this one here and get rid of that. So this would effectively then be return casting of, actually what we should do, instead of cast, we should use the as keyword. Can we do that? Cannot be used with as because it doesn't have the class constraint. Ah, yeah, of course. So if type of t is the same as type of our value is an object. so that's not going to work. Type expected. What am I doing wrong? Yeah, I can't do that. I need to give it a type. This needs to be... So if whatever it is that we're asking maps to the type that we're expecting. So we could do this. We actually need the type to be... see, we've actually got two types. We've got the TLV type and value.get type. Yes, that's what I want. I was actually going to store it. That was dumb, wasn't it? Thanks, Mongo. So, oops. We can return a casted value. Otherwise, we'll have to return a default of whatever t is. Does that make sense? Hope it does. Now the beauty, I guess, of doing this way is that if we do this during construction, then we have the ability to sort of recursively do stuff, which is kind of cool. It does get a little bit tricky though. Issues comparing typos regarding subclasses. No, I don't think there is, because that will return, typeof will return the bottommost class. So we're not using like .isInstance of. We are making sure that the types are exactly the same, right? So if where are we? So we can go type of t, and there should be a dot. Like is abstract or is assignable, is auto layout, is by ref, is class, is generic, is instance of type. So we're not doing anything like this because is instance of type would say that would probably cater for cases where things are subclassed, but I don't think that we have this concern using this because we are doing an exact match here. We want to make sure that they are exact. Like if you ask for an animal, no, this is a really key point, and it would change the game again if we were using strong types with subclasses. This thing wouldn't actually work. So it's 9:45 already. We're almost at our limit. At least we've got some code going on, right? So that's at least interesting. This is fairly messy, and we are going to tidy this up. But I did want us to just at least have a play with this, because something as simple as parsing a TLV packet nicely is actually quite tricky, right? And this is assuming we go with the binary reader approach, which I think can make a lot of sense. It certainly makes maintaining of state significantly easier. So if we do this, we then have to go through and do it for all of the meta types. What is the value of default t? Well, default t will vary depending on what t is. So if it is a reference type, like a class instance, it'll return null. If it's an integer, it'll return 0. There's a bunch of whatever the defaults are. So hang on. C#.net default. Let's see. Default values table. Here we go. Default values of value types. False, 0, char. So all of these things will be set by default when we return default of a certain value. Yeah? The other option would be to have an overload, and this is the kind of thing that I like to add over time. So if we went like this, t, we could do this. So you could say, right, give me the value, and by default, if you don't specify any parameters, and we're unable to get it based on the type that you've given, then we'll return whatever the default value is that you give us. If you don't give us one, then we'll default to this. Does that make sense? Which actually I think is a little bit nicer, and there's an implicit, hey, look, we're going to try and give you a default value if things don't work. So that would mean, like, if we're doing foo, we could go var name equals get value string, and it'll try and convert it to a string and return basically a null otherwise. But if we wanted to say, you know, if I wanted to default to OJ, then I could do that and completely get rid of this, because it knows that this is a string. This also means that we can do things like ID get value default to you see how I don't actually have to specify the types in there, because the compiler knows what types these values are, and because this type is passed in, the compiler can say, oh, we know what this is, so actually specifying the angle brackets and the type there is redundant, which is kind of cool. Maybe what we should do here is force this. Which I think is kind of cool. What do you guys think? Do you think we should force them to give us a default value? Or do you think we should imply one ourselves? Thoughts? Do we have any? What about using an optional value? No. So, look, we can get into the whole, should we really avoid the use of null and return an option of type so that we can then match against whether the type... Look, the thing is that is effectively the same as a nullable type in C# without the constraints. But I think what we're going to try and do is end up shoehorning discriminated unions into a language that doesn't have them by default, and shit's just going to get messy. And at this point, we're literally just parsing a stream of bytes into types. And there has to be some implicit trust that what we're given actually maps the value that we're receiving. So we have to stick with nulls whether we like it or not. Otherwise, we're going to end up sort of really, I think, in this scenario, making the type system around these functions unnecessarily complex, where all we really want to do is go, that value there is an integer, just give me an integer. Does that make sense? To me, it feels like if we're going to start pumping discriminated unions and option types in here, then we are starting to over-engineer. No, we can't have a nan. Bugger off. What the get value may provide may not be the same as what we want. That's exactly right. So I think what we should do is actually specify what the default value is going to be. I guess the problem there is that people will always, for a given type, specify 0 or an empty string. So yeah, exactly. And it's not really, I guess, what people would call canonical C# or, you know, typical C#, and it does start looking pretty ugly. And again, we've got to find that sweet middle ground between, are we going to go too far and make this painful to maintain versus making the code safe enough so that things don't die. Like, at the end of the day, there is a possibility that some data will come down the wire and it won't be indicative of, you know, having the right type map to the same information. And in Meterpreter land, that shouldn't cause us to crash. So we just need to deal with it. So, you know, I'm of the mind that we don't start dealing with option values and trying to get tricky, because the consumers of those APIs will just go, right, I want this value, please. Let's also not forget that we're not building in this scenario, we're not building a RESTful service, for example. We're not building an API that arbitrary endpoints are going to consume. This is something that only Meterpreter will talk to. And you know what? If something other than Meterpreter is trying to talk to it and it crashes, then that's probably a good thing. But yeah, I think we can go too far if we'll go too far if we start trying to pump things like that in for the sake of literally parsing a packet out. I'm happy to be corrected though. We control both ends of the comm, so there should never be cases where the packets have TLVs of the wrong type. That is true. If we do things correctly, that is true. But again, you know, I mean, it's easy to argue, well, you know, the famous last words, right? Famous last words. So I just thought I'd do the raw one. Now the string thing, this is going to be interesting, right? Because let's just change this to bytes equals get bytes length. And then from here we need to convert the value, convert these bytes to a string. So the question here is, what encoding do we use? So I would argue that it's system.text.encoding UTF. UTF-8 is what we use everywhere else. That's what we should be doing. Standard everywhere. Yep. Well, it's whether it's a standard everywhere isn't the point. The standard is what is the point is what is the standard in Meterpreter. Those pesky blue teamers fuzzing our shiz. Buffer overflows. Yes, well, indeed. Indeed. Righto. String raw bool keyword. Bool and keyword. So, you know, this is are people kind of happy with this approach? Do we think that we should be going, right, we're just going to basically loop through creating TLVs until the binary reader has effectively finished? So if we were to, let's say, have a packet parser, just for shizzles, right? And on this packet parser, we had a function which basically goes and creates a public, let's say, it's going to be a dictionary of TLV type to TLV. That's going to return that. And what am I going directory for? We need dictionary. So we're going to return a dictionary of TLV types to TLVs. Why are we going to do that? Because we need to be able to index into a particular TLV value based on its name, yeah? So, parse. So if we're going to parse something, we're going to parse a packet. Because we're going to get given a packet, and the packet's going to give us basically whatever data it is that we need, right? So var result equals new dictionary of TLV type. Running out of time. And TLV. So basically what we need to do is somewhere we're going to get some data, right? Now, get this from the packet. We will eventually read this from the packet, right? But for now I'm just going to be silly and go new byte 1. Just so that the type system's going to be happy with me, right? Should it be public packet parser? No. At this moment, I'm actually just defining a function called parse, so we might be able to reuse the packet parser to parse the packets into a dictionary rather than creating a new one every time. Or it could even be a static method because this is going to be pretty simple. The packet will have multiple TLVs of the same type. Yes! Yes, it will. So that means we want to have a list of TLVs. I was actually going to worry about that down the track, but given that you've brought it up, let's make it. Let's do it properly the first time. So then what we need to do is we need to create a reader, which is a new binary reader, and we need to give it a stream. So with the bytes that we've received, maybe what we need to do is go stream equals new memory stream. And we'll wrap the memory stream around the data. And reader. Right, and I think we need to do the same with a binary reader actually. Using reader binary reader stream. Okay. So then we can say while reader dot, let's have a look. Is there a property that says that we're done? Can't see one. Peak char. Returns the next available character and does not advance the byte or character position. So we want to know whether or not this thing has finished. So maybe base stream dot position. Right timeout can read. Can read. This is interesting, isn't it? Length. Maybe we just need to check if the length and position are the same. No, peak char will not return a reference type because if you have a look at this, reader.peak char, see how that returns an int, and an int can't be null. It can only be 0. So the question is, if we go peak char and we get 0, well, is 0 an indication of null byte? Well, -1 is exactly the same, right? Because that can be hex FF. So peak char, I don't think, is going to give us what we need. Did we have that over? Binary reader. Peak char. Where is it? I got to look at members, don't I? Methods. Peak char. Returns -1 if no more character is available or the stream does not support seeking. Using for easy object once finished, right? Yeah. So we wrap all of the disposable objects in a using statement. Okay, so then maybe we do need to go while peak char doesn't equal -1, which feels fucking terrible. I want to do like a while has bytes or something like that. Okay, so TLV equals, what are we looking to do? We want to go new TLV and give it the reader. Yeah? And then we can go, because behind the scenes this thing will now have a type. If our current result set contains the key TLV, sorry, if it doesn't contain it, dot type, then we want to go TLV TLV.TLV, no, result TLV.type equals new list of TLV, and then we can go result TLV.type add TLV. Does that make sense? Yes. Maybe we should add that as an extension method just to make things nice and easy, right? We could do that. We'll add some comments for now instead. So can we see what we're doing here? The intent would be if we had a packet parser that we receives a packet, or we could have at least on the packet a function that's called, dot, like 2 TLVs or parse TLVs or just parse or something similar. Then we can invoke this functionality here. But as you can see, what we're doing is we're just wrapping whatever bytes we've been given in a memory stream, which we then wrap in a binary reader, and from there, while we loop through here, we can do all this sort of stuff. What I'm doing here is I'm creating a new TLV packet, and I'm saying please read from this reader, and then we basically say in our result set, if we haven't found anything of that type before, then create a new list of TLVs and whack that in the dictionary, and then whatever dictionary and whatever list is associated with that type, we're just going to append the result to. Okay, so that also means, because we support the notion of group packets, we should also be able to create TLVs that have TLVs in them. So what would happen in here, for example, is if there's a meta type of group, then we need to create basically a new dictionary of types to TLVs and recursively create it, if that makes any sense. So let's just quickly do that. Oh, I've hit my 2-hour limit. I'm stopping. And it's tempting to kind of go on, but 2 hours is up. I'm going to stop, and in a couple of days we'll regroup. Okay, I'm not going to touch anything here. We're just going to come back immediately to this. Make sure you host someone. Such self-control. I know, self-control. Anyway, look, this code is exploratory as well. We're probably going to tidy this up. We're going to move things around. But the point is that I want everyone to understand what it is that we're trying to do. And hopefully that will make sense, and we'll end up getting something out of the end of it which is good enough, not over-engineered, not under-engineered, and all of those wonderful things. But we can get really stuck in a rut if we try and make absolutely everything perfect, where at the end of the day we're just trying to deserialize like data from a trusted source. Okay, righto. I'm going to sign off there. I am going to cut it short. I'd love to continue, but I'm not going to. As promised, 2 hours is enough for everybody. When we come back in a couple of days' time, we're just going to carry on from here. We're going to refine this a little bit. We're going to get some data out of MSF, and we're going to actually start pulling packets apart. Okay? So thank you again. Thank you again for everyone's attention. I do appreciate it. Those 2 hours really did fly by. I appreciate everybody else's support and interest and all of those things. Very, very grateful for that, as always. Where are we? Let me go back to my ugly face. So sing out if you have any questions. I will push all this stuff to GitHub as promised. But yeah, thank you as always, and peace, be good, and I will see you guys later on the tubes. Ciao.